Welcome and Namaste. Myself, Dr. Mallikarjuna I, Assistant Professor, Selection Grade, working at Maharani Science College for Women, JLB Road, Mysore. Our college is an autonomous college, and the series of modules in this course, I would like to present as per the CBCS syllabus is concerned. I am teaching for the program MSc General Chemistry and the course Physical Chemistry, and paper of the title Advanced Physical Chemistry Hardcore 3.3. In this present lecture, I would like to give a brief outline of the syllabus as per the Advanced Physical Chemistry paper is concerned. Yes, this paper consists of 3 units of the duration 48 hours, and each unit consists of teaching hours 16. Unit 1 talks about advanced chemical kinetics. Unit 2, electrochemistry. Unit 3, fundamentals of crystallography. I will be covering in my series of lectures for only Unit 2, electrochemistry, and Unit 3, fundamentals of crystallography. Before going to the actual syllabus, in this lecture, I would be presenting a brief outline of what are the things present in Unit 2 and Unit 3. Hence, I would like to share a screen to give you a brief outline of the syllabus. Yes. A quick glance at course CHP HCT 3.4, Advanced Physical Chemistry, Unit 2, Electrochemistry, which is of 16 hours duration. And what all the syllabus contains in this electrochemistry is electrochemical cells and batteries. You know the electrochemical cells and batteries. You have a background knowledge that you have studied in electrochemistry of the undergraduate courses. The electrochemical cells and the batteries, the fundamentals of the electrochemical concepts behind it. It may be started from the definition of the electrolyte and the theories of the electrolytes. And that basic knowledge is highly required to study this paper. And what all we cover? The introduction, that is about what are electrochemical cells and batteries, and what are the differences between this, and the galvanic cells and electrolytic cells. You know, the electrochemistry is an interconversion of electrical energy into chemical energy, or a chemical energy into the electrical energy. The galvanic cell is a cell which brings about the electrochemical reaction which generates the electric current. But the electrolytic cell, as the name itself indicating the electrolytic, the electrolyte which undergoes lysis, it means it undergoes breaking into the cations and anions into the respective electrodes at the expenses of the electric current. That is the difference between the galvanic cell and electrolytic cells. And we'll be studying the construction of a galvanic cell and electrolytic cells and the differences between the galvanic cell and the electrolytic cells. And the schematic representation of a cells. What is a schematic representation of a cell? You know, the schematic representation of a cell, the galvanic cell, it may be, there are different types of the cells are there. You know, the electrochemical cells with concentration, without concentration, with transference and without transference. There are different types of cells are there. How to represent symbolically these cells? Okay, we have a diagrammatical setup, but this diagrammatical setup is not always a convenient way of identifying immediately the type of the cell. Means which is a electrode, a left-hand electrode, which is a right-hand electrode, and how these left-hand electrode and right-hand electrode connected by a salt bridge. So therefore, we have a type of a system to represent the cell schematically or symbolically, that is called as a schematic representation of a cell. Faraday's laws, mass transfer in cells. Yes, there are two laws in Faraday's, as per the electrolysis theory is concerned. The Faraday's first law of electrolysis and Faraday's second law of electrolysis. The Faraday's laws mainly focuses on when the electrodes dipped in an electrolyte, when the reaction is taking place, how these cations will be discharged at the cathode and anions will be discharged at the anode, and what is the amount of the substance which would be deposited at the respective electrodes. This Faraday's laws will tell us about during the electrochemical reaction, you are supposed to have a quantitative estimation of the amount of the substance deposited with respect to the quantity of the electric current passed in an unit time t. And batteries, in batteries we are going to study the classification of batteries and the characteristics of a batteries. Nowadays, you know, most of the roadside vendors, including the very big shops, are dependent. They're not dependent on the electricity boards. Whenever the power shuts down, during the time, many people are dependent upon the UPS, that is uninterrupted power supply, connected to the mainly the lead acid batteries. Even in our what we are using, the mobile phones or the electronic equipments, mainly consists of the batteries. Without these batteries, we cannot use any of the electronic devices nowadays. So there are different types of batteries, like primary batteries and secondary and lithium batteries and fuel cells. And what are primary batteries? What are the examples for the primary batteries? And what are the characteristics of the primary batteries? Secondary batteries, what are secondary batteries? And lithium batteries are one such kind of that we are going to study the electrochemical setup present in the lithium batteries. Nowadays, recently, we have heard a news that CSIR is going to launch a fuel cell based car in India. So the fuel cell is very research during this energy crisis time. So what are the fuel cells and how it would be able to produce the electricity, or how it would be generated, the electricity or generation of the electricity by the fuel cells. And electroplating, the electroplating is one of the important phenomenon or a procedure for coating of a certain desired metal onto the another metal. So electroplating nowadays is a very big advanced topic for the research as well as for the industries. And what all we are going to study in this is theory, that is how electroplating is done, and definition, mechanism of electroplating, that is how we are going to adopt a procedure to coat a particular desired metal onto the surface of the other, and effect of plating, variables on the properties of electrode deposits. Means why this electroplating is to be done. There should be some properties should be coming out of that. There should be some advantages of doing electroplating. So what are these? Comparative account of complexing and non-complexing baths. This complexing and non-complexing baths is specially included in the procedure of electroplating. And additives on plating baths and their significance. Means during a plating technique, we have to add some of the additives as a chemical substances for some of the essential purposes. And metallic coating. In metallic coating, we'll study the electroplating of copper and chromium, and why you have to coat this copper and chromium. And preparation of substrate surface. Means to coat any of the other desired metal onto the other surface, how to prepare or how to make ready the substrate surface for the coating, and application of gold and silver plating. Next, after this, we are moving to the last chapter of the electrochemistry, that is the corrosion. In corrosion, you know, the corrosion is a very unavoidable phenomenon in the nature. Anything which can be exposed to the atmosphere, that is carbon dioxide, oxygen, or a moisture, which should start deteriorated or degradation will be there for any of the metal or any of the material. So this would become unavoidable phenomenon, any substance which is exposed to in the nature. So this corrosion, you know, this is an electrochemical phenomenon, means that the electrochemical reaction will be taking place on any of the substrate or any of the substance where it undergoes a corrosion. Definitely there should be some corroding element should be there, like carbon dioxide, oxygen, or moisture like, and it forms a cathode and anode on the surface of the material which undergoes degradation. So the corrosion is not a physical phenomenon, it is an electrochemical phenomenon. A big electrochemical theory is involved in the process of the corrosion. So what is the basis of the electrochemical reaction? Means how this electrochemical corrosion should be taking place. And that is what the theories and mechanism of the wet corrosion. And since I said this corrosion is an electrochemical phenomenon, means it is an electrochemical reaction like a normal reactions, but it is an electrochemical reaction. How you are conducting experiment in a thermal reactions in the laboratory. This is a corrosion is an electrochemical reaction. Therefore, for any reaction, the thermochemical concepts, the thermodynamic aspect should be come into picture. So what are the thermodynamic aspects of the corrosion? Means when the corrosion is taking place, as I said, there is an electrochemical reaction, that is a redox reaction may be taking place, that is reduction and oxidation. And the thermodynamic aspects of this reaction means what is the change in free energy, what is the change in enthalpy, what is the change in entropy, and what is the equilibrium constant. All these points and should comes into the picture of the thermodynamic aspects of the corrosion. And there is one of the important aspect we are going to study, the concept that is event diagram, that is current potential relationships, that is called as event diagram. This is very, very new to you, that you are not studied in the undergraduate, that is the non-BSc honors course. So factors influencing the rate of corrosion. What are the factors which influences the rate, which increases the rate of corrosion? Metal and environmental factors. So the metal and environmental factors means many of the devices or many of the industry sectors using the metals. Say for example, aircrafts. Aircraft is always in the environment, that is in the stratosphere zone, where it is exposed to much of the atmosphere. So how these environmental factors will affect the metal for the corrosion. So kinetic aspects of a corrosion means, the kinetic aspects means when you set a reaction, there should be a thermodynamics comes into picture and kinetics also comes into picture. So what are the kinetic aspects of the corrosion? Means how do you measure the rate of the corrosion? Like a normal reactions you are carrying out in the laboratory. So you have determined the rate of reaction for many of the reactions in the laboratory in the undergraduate or in the postgraduate, like the reaction between K2S28 and Ki and hydrolysis of an ester. Likewise, we can also measure the rate of the corrosion reactions. That how you are going to measure a corrosion rate? By different methods, and chemical and electrochemical methods. In this general aspects of corrosion prevention and control, how do you control the corrosion? You cannot avoid completely the corrosion, but you can prevent the rate of the corrosion on the surface. So therefore, which material we are going to use, we have to design in such a way that the prevention of the corrosion should become maximum. Say for example, we are using the wooden doors, we are using the metal objects. These would be coated before we are using, maybe like a metallic painting. Why do we do that? Say for example, bikes, cars. These are used as a metal, and where the metal is coated by the paint to prevent the corrosion. So what are the general aspects of corrosion prevention and control? That is what the designing aspects. And effect of alloying, there is a spelling mistake, kindly excuse me, and surface modification. Effect of alloying on surface modification. Why do you do surface modification? Surface modification means I have a plain iron surface. I do modify this surface by adding other metal or other substance to prevent the further corrosion of the alloy. So that is an effect of alloying. Why will go for the alloying? Only to prevent, one aspect is to prevent the corrosion and to change the properties or to enhance the properties and to bring out some of the desirable properties. So in surface modifications, we have a cathodic protection. This cathodic protection will prevent the rate of corrosion. There is also anodic protection. This we are going to study. And corrosion inhibitors. Corrosion inhibitors means while taking place the corrosion, by adding some of the additives, we can prevent the corrosion. That is what all we are going to study is introduction, classification, characteristics, requirements of efficient corrosion inhibitors. Means apart from the surface coatings at all, the inhibitors which can inhibit the rate of the corrosion. Recently, there are green inhibitors are being coming into implementing. Therefore, what are the green inhibitors? How these green inhibitors are preventing the rate of corrosion? Then corrosion prevention by painting, phosphoting, anodic, that is passivation technique, and their significance, corrosion inhibition mechanism.